Hi, good morning, everyone. This is Dr. Lisa Smelser again. I wanted to give you an overview of what to expect for your labs, where to find them, things that you may need, and then go over our first lab together. So all of the labs are going to be embedded within the unit that they're connected with. They'll have due dates that are posted in the calendar, and depending on when different assignments fall, those labs may be due on a weekly basis. So I would anticipate that, but that's not necessarily going to be the rule. We have less labs than there are weeks in the semester. And so I would expect it to be on a weekly basis, but know that that may not be exactly true. And lab assignments may be due for that unit after a lecture exam. So I try to be very aware of the deadlines that I'm assigning to make sure that you are set up in the best possible way for success. That doesn't mean that you won't have assignments due on the same day, but if we have an exam due, then I try to make sure that any assignments are either due before that exam or after the exam. So hopefully you have completed the blog 1 with our introductions. If not, there is still time, so that's available right outside of Unit 1. And then with Unit 1, you can see a list of the assignments that are due. So these are things that you need to make sure that you're submitting. Everything is available or will be available shortly, except for our osmosis and mitosis labs, and then the show what you know science as a process, and that's what I call exams. I think show what you know is a much more friendly term than exam, and I will update that to make sure that it's a little bit more clear. So to find your labs, you're clicking into the unit. You could also access them from the calendar either way. If you've noted, I've added some steps in here, so hopefully that helps organize this section a little bit more for you. And what we're looking for is the Unit 1 Lab 1. And so I've got some steps for you here as well. So the first thing will be to watch this video that I'm making for you right now, and that will be posted up here. And you'll want to watch the video with this file that is loading open. And this file will be the basis for your lab. It will have some activities for you to do independently. You can also work with a partner if you know someone in the class. Just make sure that you're following academic integrity expectations, meaning if one person does the lab, you cannot just copy it and submit it for yourself. So you would have to be working on the lab together at the same time and creating your own information. So that means that I would not expect to see two people submit the exact same files. There are always slight variations. So I suggest doing this part after you've gotten started with Chapter 1. There's information on hypothesis testing as well as graphing in Unit 1 lecture, and we are building on that information. Key things when you're completing this document are up here at the top, and this is kind of your checklist. So for something to be considered a scientific hypothesis, it must be testable. So that means we have to be able to collect data on it. So if we cannot collect data on it in a way that is controllable, then that particular statement cannot be tested scientifically. It doesn't mean that it's not another way that we know things. It just means that we can't test it scientifically. And different disciplines have different rules as to what counts as evidence and what's the threshold for characteristics of that evidence. And for science, this is this is what we have here. If you are taking a religion class, or if you're taking a philosophy class, the level of evidence or what counts as evidence might be different. Not that it's better or worse, but that science has to make sure that we play by these rules so that we can be certain that the information that we gather is as accurate as possible. And then, so when we're looking at these statements that I have listed, and I'm asking you to assess if the statement can be a scientific hypothesis, you're coming back up here to the list. So is it testable? Can we somehow find or construct an experiment to get data? Is it controllable? Meaning that there are not things outside of our control, like the weather, for example. So if we're testing the relationship of activity of something outside, weather is something that we cannot control for. That doesn't mean that we can't collect data on it and maybe make some correlations to further test it, but that particular statement cannot be considered a scientific hypothesis if it is not entirely controllable. If it's falsifiable, so this kind of goes back to the testable part, and falsifiable means, is that statement a yes or no? Can we say, yes, this data supports the evidence, or no, it does not support the evidence? So I really stay away from the wording of proving or disproving, because science as a whole is a body of information, a body of knowledge, and just because one particular experiment, one particular set of testable variables produces certain responses, that doesn't mean that a different experiment would give you the exact same results. And that's why you see, hundreds upon thousands of scientific studies that are on the same topic. I did my doctoral dissertation on the drug simvastatin. So it's a cholesterol lowering medication. Statins in general are a class of drugs. And what they have found is that based on the dosage, based on additional medical considerations of the patient, statins could either increase an immune response, or it could decrease an immune response. And so for a very long time, still currently, the scientific community kind of goes back and forth with saying, well, are statins boosting our immune system, or are they tanking it? And the answer really is a little bit more complicated than that. The answer is it depends. It depends on the testable variables. It depends on the way that it's being used. So sometimes science can seem like it is saying one thing one day and saying another thing another day. So it's really about the specific conditions, the specific testable conditions that are controllable in an experiment. And so we can say, yes, in this particular scenario, the data is either supporting or refuting the hypothesis. It also must follow the rules of nature, so meaning it is not supernatural. So science cannot test that. It's not saying that that's a bad way to know, or that it's not a way we can know things. It's just saying that the scientific method cannot apply to those scenarios. And also, it's not a matter of opinion. So we cannot have a scientific hypothesis be a matter of opinion. What we can do is have scientific data that supports, or that is based on a hypothesis that we can use as evidence to help us construct our opinions. So the opinion itself is not a scientific hypothesis, but there might be a different statement that helps us make sense of those opinions and help us understand the world around you. So in this document, you can type directly into this document, and you can upload one file for the lab. You could also upload 2 different files, your responses to these activities, as well as your graph that you're going to make. So when you get down to these statements, UV exposure causes skin cancer. So that is a statement. And so what I need you to type is if you think it is a scientific hypothesis, and write an explanation why. And again, refer back to this part up here at the top. If it is not a scientific hypothesis, then you need to explain based on at least one of those characteristics that it does not meet. And then what data could you possibly collect that would allow you to say, yes, the hypothesis is supported, or no, it's not. And so that's what we're looking for each of these 5 statements. So this isn't an activity where you're Googling, are birds closely related to dinosaurs? Excuse me. You might need a little bit more information to help you figure out what the data could be, and that's fine, but you really need to come back up here and go through, is it testable, is it controllable, falsifiable, following the rules of nature, and not a matter of opinion, and address that here in your assessment of each of the 5. Then you're coming down here. So hypothesis and predictions are very similar. You could say that a prediction is a hypothesis, but a hypothesis may not necessarily be a prediction. So most of the time I try to write my hypotheses in if-then format, and that makes it a prediction as well. That makes sure that it is very clear what you think is influencing what. And so what you're going to go through here in the practice and do, type in here a testable question that you want to answer about diet and obesity or body weight. So maybe a question could be, and you can't use my question, can you be fit and be overweight? So that might be a question that you're interested in. Questions may vary in terms of how broad or how specific they are. Sometimes that is really going to be up to the researcher, which is you in this scenario. But with my testable question of can someone be fit and technically characterized as being a higher body weight, I might have to define, well, what does fit mean? And not that you have to spell that out, but keep that in mind. So keep in mind any terms that are maybe a little bit vague. In a scientific experiment, you would have to specifically designate what that actually means. From your question, you're then going to write a hypothesis or a prediction. I really like the if-then format. I think it gets your hypothesis where it needs to be. So you could say, and this is where you could be a little bit more specific. So you could say, so what did I say? Okay, so my question is, can a person be obese and fit? So my hypothesis or prediction might be, if a person is obese, then and just as you're seeing me do here, this may take a few times for you to kind of get the wording. If a person is fit, they could also be obese. So you're saying that if we have a person that is fit, then they could also be obese. So saying that that's a possibility. And so you are testing and collecting data about the relationship between the fitness of someone and also their weight. And as you're going through to further define what data you would collect, you may collect body weight, And maybe you're interested in strength specifically. So maybe body weight and maybe how much weight can a person squat. So you're looking for uh, a relationship or not between someone's body weight and then also if they can lift more weight or not. That is just one example. Your example is going to be a little bit different than mine. So variables need to stay the same, are everything except the variable that you are testing. So if you have a person on a, let's just say, a 10-week weightlifting plan, and you're testing if body weight has an impact on how much someone can squat, anything that could impact your results besides the training plan that you are administering need to stay the same. And this one might be a little bit difficult. I probably could have picked something better, but their diet needs to stay the same, any of their medications, that sort of thing. When you're looking at your independent and dependent variables, maybe your body weight is going to be the independent variable, and the squat PR, we'll call it, is going to be your dependent variable. And so your independent variable is going to end up on the x-axis. Your dependent variable is on the y-axis. So what we're really saying is a person's body weight is going to depend, or I guess the squat PR is going to depend on a person's body weight. So we're predicting if you weigh less, you're going to be able to lift less. And if you weigh more, you'll be able to weigh more, or you'll be able to lift more. And that is our measure of fitness. How much can you squat? And so that's just one particular example. Feel free to go in different directions. It just has to fit under the topic of diet, obesity, and body weight. It could also just fit underneath the category of kind of health and wellness in general. That's fine. You'll do a second example like that for environmental effects on plants and animals, and you'll go through that whole process. And so the last part of this assignment is to make a graph. You can use this graph paper if you like, and then when you graph your data, make sure you write an analysis and a conclusion. And so you could continue on in this document, or you could create a graph that is in a separate document, or you could copy it in here. Where is the data, you ask? The data is going to be here. So after you've kind of stepped through the hypothesis and the experimental design development, you'll want to watch this good graphing video. And actually, you might want to watch the good graphing video first because that will give you an idea and examples of the independent and dependent variables. You'll get the graph data that we're looking for here. And so I'm providing you with the data. You're making up scenarios for the other two kind of walkthroughs of hypotheses development. And so I'm giving you data here. Only pick one of these two data sets to graph. So I've got body weight and exercise data here. So that's one set of data that you could graph, or you could choose to do the environmental data. So I lived in Florida most recently, and Cuban tree frogs are invasive and they kill native frogs. So we're trying to see if there's a relationship between the number of invasive Cuban tree frogs and the number of native frogs that we count. So those are two options there. So that is where you find your data. And I've got a how-to video here of how to make a graph in Excel. You could also hand draw it on that piece of paper if you want. You have a choice. All of the components of your graph that are needed can be found up here in the Good Graphing video. Once you get through all of that, what you are submitting to the assignment are your responses from the hypothesis development and your graph. So I really need two things. I need your responses from this assignment and I need your graph. And that all can be submitted by clicking here. Reminds you when the due date is. That's also on the calendar. How many points are possible. It gives you the instructions again. And then I suggest typing everything into that Word document and then copying and pasting your graph in there. You can also browse files on your computer and upload a file. For smaller assignments that don't require quite so many components, you can write a text submission, and that's fine. We might do some reflections later, but I generally suggest uploading files. That way you have it saved and you don't accidentally use it. Do not do the save as a draft. It gets a little bit lost and it is very difficult to find it. They say that you can find it, but it's not as easy as that. I would create all of your documents separately and then upload. If you have any additional comments, you can put them in there, but not necessary, and then you will hit submit. If you have questions, feel free to email me, or I've got my virtual hours. Have a great day.